This section is all about ellipses. And ellipses are pretty easy to think about or to understand if you think about them in relation to circles. So in circles, basically you have a radius, and all of the points of a circle are a fixed distance away from the center. Right? I mean, that's how you just make a circle. So it's just this constant distance from here. And the equation for a circle is x squared plus y squared, well, when the center is at 0, 0, is x squared plus y squared equals r squared. Because what you have is like, this is the point xy. And notice it goes over a certain amount x, up a certain amount y, right? If this was 0, 0 and you're graphing it. And then this is just the Pythagorean theorem. Like every point on here, that r is this distance, that r squared is this distance squared plus this distance squared. So that's how circles work. And if I think about just graphs of circles, something like this, if I had x squared plus y squared equals 25, notice that has a radius of 5, right? And if I make that a 9, this has a radius of 3 all the way around. You can see that. Now notice what I could do here too is I could start to shift this off of 0, 0. In other words, if inside the squaring of the x I said x minus 3, inside the squaring of the x I went x minus 3, notice that moves it right 3. So now my center is at this point 3, 0. And if, let's say I wanted to move it down 2, I would say, whoops, y plus 2. So notice my center now is at the point, what makes this a 0? 3. What makes this a 0? Negative 2. Yeah. Plus, if I wanted to, I could divide everything here by 9. In other words, instead of saying this is equal to 9, I could say if I divide this by 9, divide this right-hand side by 9, I get this. And divide this, left-hand side. And if I divide this right-hand side by 9, I get 1. And I still have the same shape. So there's our basic idea of a circle. I can move things left and right here. I can move things up and down here. Now what I can do is I can start to think about, and this is where it becomes an ellipse. What if I'm offset by 3 in this x direction, because that's the square root of 9. Offset 3 in this y direction, because that's the square root of 9. What if I made this a 16? Notice what happens now in this x direction, because it's under the x. I'm out here. This distance is 4. This distance is the square root of that. And this distance is the square root of that. And that's how I can graph ellipses. I can say, like, where do I want the center to be? I want it to be at, let's say I want it to be at negative 5, positive 6. And in the x direction, I want an offset of 10. Well, then I would make this 100. In the y direction, if I want an offset of, let's just do 4, I would make this a 16. So notice there's my center right there at the point negative 5, 6, right? The opposites of those values. And then in this direction, I'm offset by 10, the square root of that, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this point right here, notice it's negative 15, 6. I've added 10 to the x value. Y value stays the same. And if I get up to here, the x value is the same. Well, if I get on it, negative 5, but I've added 4 to the y value. Right? From 6 up to 10, I've added 4. That's the basic idea for graphing these ellipses. So if I back up for a second and I think about a definition for an ellipse. For a circle, it was all the points that are a fixed distance from a center. For an ellipse, what we can do is we can split the center into 2 pieces. It still has a center, but what I do is I'll go 3 this way and 3 this way. Now what I get are called foci. This is the first focus, this is the second focus. And the ellipse might wrap around it, something like this. And it should look a little rounder than I've actually drawn it, but you get the idea. the way that these points on here, these xy points are on here, you have a distance from one of the foci and a distance from the other foci. And if you add those together, if you go distance 1 plus distance 2, you get a constant number. You always get the same value. So any point that's on here, if you go this distance plus that distance from the foci, you always get the same number for that ellipse. That's a locus of points, a collection of points definition for an ellipse. Just like for a circle, it's just everything's a constant distance from the center. So this idea of an ellipse, there's some stuff in your book about it, and it's actually a pretty good description. So if we have it in this form, x minus h squared over a squared, y minus k squared over b squared equals 1. The center's at hk, so you can see centers at hk on each of these. And then that a is this, the a, whatever's underneath the x, is this distance from the center to this edge. Notice it's h plus a here, right? And k stays the same, the height is the same. H minus a. And then for whatever's underneath the y, you square root that b, and that's offset in this direction. So that's pretty straightforward on both of these. Notice these are different sizes. In this case, the thing that's underneath the y is larger than the thing that's underneath the x. And in your book, they like to switch them, call the a the bigger one, which you can do if you like. A couple other pieces of definition here is the longest one is called the major axis, and the shorter one's called the minor axis. And then we have these foci, and the foci always lie along the major axis. So here's a focus, and here are a pair of foci as well, focus and focus. Now, again, this distance is, in this one, it's b, right? It's what's underneath the y in the y direction. This distance is a, what's underneath the x. And in this case, they just switched the b and the a. Now we have a distance to the foci, and that distance is called c. And it comes from this equation right here. So here's what I want you to notice. Our general form, x minus h squared over a or b squared, whatever you want to call it, y minus k squared over b squared equals 1, always equal to 1. And now if we take these, the a squared and the b squared, and we combine them with the opposite operator, so I'm going to go a squared minus b squared, and just go whichever one's bigger minus whichever one's smaller, that's equal to c squared. It's almost like an anti-Pythagorean theorem, right? You're subtracting instead of adding. And so that distance, this distance right here is c. That's how you can tell where the foci are at for this. So I'm going to sketch a couple graphs here. So here is, here's this. So I notice my center's at 0, 0. So I'll just call this the point 0, 0. My offset in the x direction is the square root of that is 2. So it's going to go over 2. Boop, boop, boop. My offset in the y direction is 3, right? Because this is 3 squared. So this is the point, whoops, 0, 0 is what I meant to write here. And this is the point 1, 2, 3, 1, 2, 3. Notice this distance is 2. That comes from the square root of that. This distance is 3. That comes from the square root of that. And then I like to just think this isn't part of the graph, but it kind of just makes this little rectangle framed where there's my center. And then it makes it easy to sketch it in here. This will actually help us thinking like this way when we talk about hyperbolas as well. There it is. Again, the dots aren't part of it. The xy's are these collection of points along this ellipse. I've got this center here that's at 0, 0. I've got these vertices along the minor axis. This one is over 2. So I'm going to add 2 to the x, so 2, 0. Subtract 2 from the x, negative 2, 0. This is a distance of 3 here, so I'm going to add 3 from the center to the y part, 0, 3. Subtract 3, 0, negative 3. And then I got to figure out where my foci are at. And so remember, foci are opposite operator of these combined. So I'm going to take the bigger one, 9, that's b squared or a squared, whatever you want to call it, minus 4, and that's equal to c squared. So 9 minus 4 is 5, that is c squared. So c is the square root of 5. Square root of 5 is like 2 point something. So if I talk about where my foci are at, they're along the major axis, 2 and a little bit, 2 and a little bit, and I could label this point as the x hasn't changed, no left-right movement, but it went up root 5. And then this one would be the point 0, negative root 5. Yeah, let's do another one. My center is at the point 3, 4, right? And I'm offset a distance of 5 in the x direction and an offset of 4 in the y direction. So if this is the point 3, 4, in the x direction, I'm going to go 5 units. So 1, 2, 3, 4, 5. Back 5 units, 1, 2, 3, 5. And I'm basically adding and subtracting 5 from that x value because it's x. So 3 plus 5 is 8. This is the point 8, 4. 3 minus 5 is negative 2. This is the point negative 2, 4. Offset of 4 in the y direction. 1, 2, 3, 4. 1, 2, 3, 4. So if I subtract 4 from y, that's 3, 0. Add 4, 3, 8. And again, this is not part of the shape, but I'm just going to draw this box just so I can sketch it better. Again, this will help me when I do hyperbolas. So my ellipse looks something like this. And then I just need to figure out where my foci are at. Foci always are along the major axis. So remember, I'm going to grab these and combine them with the opposite operator of that. So 25 minus 16 is c squared. That means that 9 is c squared, so c equals 9. No, it doesn't. The square root of 9 is 3. C is 3. So I'm offset by 3 from here. So over 3, 1, 2, 3. I'm going to add 3 to the x value. So 6, 4. Back 3, 1, 2, 3. I'm at the point 0, 4. There's a sketch of that. Do a couple more here. All right. Now be careful because this is written in a different order. Notice the y is coming first and the x is coming second. We just need to keep track of something. My center is at, what makes this a 0? 3. What makes this a 0? Negative 5. I'm offset of 3 in the y direction. I'm offset of 10 in the x direction. It's under the x. So I could sketch that. 3 in the y direction. 1, 2, 3. Negative 5 minus 3 is negative 8. Negative 5 plus 3. Offset of 10 in the x direction. So again, this offset in the x direction is 10. So 10 plus the x value would be 13, negative 5. The x value minus 10 would be negative 7, negative 5. I'm going to frame it out. Catch it. Could be drawn better, but I will live. Now I'm going to determine where those foci are at. These two combined with the opposite operator. So bigger one minus the smaller one. What's that, 81? Nope, 91. 81 would have been convenient. 91, so that's going to be square root both sides. C is the square root of 91. Square root of 91, it's a little bigger than 9. So my foci are way out here, a little past 9. And the way I can write these, it was a change in the x direction, right? I can just say 3 plus the square root of 91 and the same height. 3 minus the square root of 91 and the same height. And there's a full sketch of that. All right, let's write an equation for this. We know some things. We know where the vertices are, where some of the vertices are, and we know where the foci are at. So let me think about that. Vertices are all at negative 2, like the x value is negative 2. So everything's lined up when x is negative 2. And then we have all these different y values coming off of it. So I'm going to figure out where the center is at for this thing. And the center's going to be like halfway between the vertices, right? So negative 2. Well, I know that the x part of the center must be negative 2. So I know that this will have an x plus 2 squared in it over something. have y squared something's equal to 1. Let's get the rest of the pieces. So the y part will be halfway between the negative 8 and the 2. So I can just average those. Negative 8 plus 2 divided by 2. Negative 6. Negative 3. So that means my center is at the point negative 2, negative 3. So that means this must be a y plus 3 squared. Okay, now this tells me it goes out to negative 8 and back to negative 2. So negative 3, negative 4, 5, 6, 7, 8. And then out to 2. Negative 2, negative 1, 0, 1, 2. So this distance is 1, 2, 3, 4, is 5. So this must be, oh, yeah, that's in the x direction. This must be a 25. Okay, now I know that it does this. Now I know the foci are here and here, right? Negative 2, negative 7, negative 2, 1. So that means my c value is 4. So I've got here what I'm going to call my a value is 25. A squared is 25. C is 4, so c squared is 16. So to get this value, I know that this combined with that is that squared. Okay, that should be easy then. Let's see, subtract 25 from both sides. What's that, a 9? Negative 9, so b squared is 9. Okay, and this value is not b, it's b squared, so that just needs to be a 9, which tells me that distance there is 3. I'm in great shape. Okay, cool. Notice that has all the pieces in it. Again, if you're having some trouble thinking about the pieces, go back to this part in your book, take a look at it in your online book, and take a look at where all the pieces are from. Okay, one more thing here. Now, sometimes we'll get something that's like in a form like this, and we want to be able to graph it. So we'll have to do a little bit of work. So like one of the things is this has to be equal to 1 in order for us to graph it. So I'm going to divide everything by 100 here. 1. 4 divided by 100, that leaves me a 25 in the denominator. 25 divided by 100, that leaves me a 4 in the denominator. And hopefully you see all the pieces now. The center's at 0, 0. You can figure out the offsets in both directions. You can get the c values. Now this one is a little more work. I've got stuff messed around all over the place. So what I'm going to do is I'm going to put the x's together. I'm just going to kind of rearrange the deck chairs here and put the y's together. I'm going to subtract 100 from both sides. I've got this. And now what I want to do is I want to write these as something squared, right? I want to write these as like x plus something squared or minus something squared to get it in my graphing form. So I'm going to have to complete the square on these. And in order to complete the square, it's something that you have done before. I just want to remind you that like if I have x plus a squared, that's the same as x squared plus 2a plus a squared. So you can take half of the middle term and square it to complete a square. So first thing, I need this to be a 1, so I'm going to factor a 4 out of here. Oops, I factored a 4, so that's a 10. And I'm going to end up doing the same thing with here. I'll divide a 9 out of here. Y squared minus 4y equals negative 100. Okay. So now I'm going to complete the square on this because I want to be able to write this as like x minus something squared. And so half of negative 10 is negative 5. If I square negative 5, that's a 25. So I've just completed the square here. But notice like I've offset this thing, right? I've added this 25. So this left side is heavier than that right side. And I've added this 25, but this 25 is multiplied by 4. So it's really worth 100. So I need to add 100 to this side to balance it out. I'm going to do the similar thing over here. Half of negative 4 is negative 2. If I square that, that's a 4. I've completed this square, but that 4 is really worth 36. So I'm going to add 36 to this side as well. Okay, so now I'm going to clean some stuff up. Negative 100 plus 100 is 0 plus 36 is 36. Over here I have 4 times. Now I did this add 25, offset it with 100, so that I could factor this thing to x minus 5 squared. Plus, I've got the 9, same thing here. I did all this work so I could factor this to y minus 2 squared. Now it's almost in my form. Divide everything by 36. And I've got 4 over 36, that leaves me a 9. X minus 5 squared over 9. Plus 9 over 36, that leaves me a 4 in the denominator. Equals 1. Now it's in my graphing form, where I know the center, I know the offset in the x direction, offset in the y direction, and I can get the foci from there as well. All right, last example like this. Same thing, it's already, I think that should be squared. It's already kind of arranged. I got the x's together, I got the y's together. Okay, so first thing I'm going to do then is, let's move this thing over. So subtract this from both sides. Here it's already a leading coefficient of 1, so I'm good. Here I'll factor 100 out of these two terms. Okay, give myself a little bit of space here. Let me complete some squares here. Half of 2 is 1, so add 1. Do that to both sides, keep it balanced. Half of negative 10 is negative 5. Squared that is 25, but it's really worth 2,500. And let's see, we did that so that we can factor this to x plus 1 squared plus 100. This becomes y minus 5 squared. And then if I add all these up, add the 1, add 2,500, I get 100. So now I divide everything by 100 to get that equal to 1, get it in my graphing form. And I get x plus 1 squared over 100 plus, that's basically going to, I don't need to write it, but that's a 1 down there. Y minus 5 squared equals 1. And then from there I can tell that it's like this is an ellipse. Its center is at negative 1, 5. Oh, it's really skinny. It goes like out 10 in the x direction and only up 1 in the y direction. I could get my c values from there and then get my foci from there. All right, give those problems a try. Let me know what questions you have. Message me or post them in the forum.